from WCI3 Plus. With your host, Kevin Lighty, this is Behind the Forecast.
What's up, everybody? Welcome in. It's Behind the Forecast. That's me right there. I'm Chief Meteorologist Kevin Lighty. Thanks for joining us here. Also, give me a little like and some follows up here on these different platforms that we've got. I'd love to have you follow along when you're not here with us on the show, because we're only doing this once a week, right? But we're always doing the weather all over the place all the time. So go ahead and follow along. Okay, coming up, second half of the show, as we always do, we do an interview with someone in the weather science kind of field. And, we've kind of done a lot of the very, I don't want to say basic, but, well-known, people we've kind of talked to. But we're going to kind of go a little deeper this time and talk about rocks. And you'll be like, rocks? Andrew Guertin is a fourth-year PhD candidate, University of Illinois. He has been studying about how rocks and weather and the weathering of rocks and CO2 release and all that has a impact on our climate, and just some interesting stuff here. It'll make you think a little bit. So we're looking forward to that here coming up in the second part of the show. But let's get to the viral weather videos here. And of course, we always count them down here from 5 to number 1. And boy, we had some of this here. Actually, this past week, some hail. This is all the way out in Arizona, in Tempe, Arizona. And you can see some of those hailstones, and not too bad. But out there, you get some hail. Actually, out there in Arizona, they get any kind of weather. And the rain, it floods. I mean, it's a concrete jungle out there, so they often have some flooding problems. And so does all of, California. They've got all kinds of problems. And I mean that in the nicest way, but there's a lot of natural disasters and things that seem to happen out there. And the reason I bring that up is because the next 4 videos all come out of California. And here we go. Another wildfire out there you can see in Crowley Lake, California. The Pack Fire in Mono County, California, sending plumes of smoke billowing into the sky. Scorched more than 3,400 acres, okay? According to CAL FIRE, that 3,400 acres, still trying to get it under control. 15 structures have been damaged by the wildfire. So it's always an ongoing thing out there. But this is something wild, too. Look at this. This is number 3 video. That's trash. You're saying, what is this? This is along Long Beach, California. A massive haul of trash and debris from storm runoff from a series of storms piled up trash in a catch basin in Long Beach, California. How about that? They had to use a crane to get out there to basically try to remove the items. But look at that. Just all of that trash. There's a crane trying to do its thing to remove everything. But wow. So again, out there, it's just so different with their terrain and how things are. When it rains out there, it can get pretty wild, but just look at that. All of that debris that got piled up. All right, video number 2, still in California. And it's going to be from storms that came through. This is actually Los Angeles, L.A. Large tree that was uprooted and fell. So we're seeing kind of some nighttime video. We're going to see some daytime video here in just a second, and it'll show you. It's how big this tree is that really got me. I mean, and when we show it to you in the comparison on top, look at this thing. Look how big, the trunk of that tree is. I think it's huge. I mean, look at that. I mean, it is as big as the car. So, wow. So that's what happened when storms kind of came through out there, caught a little wind, and they actually had 3 to 6 inches of rain. So pretty wild stuff. So there's your number 2 video. All right, we keep it in California, but maybe we have a little more fun with this one after all the disaster that you see there. This is kind of funny. Here we go. Hey, who's this guy? Well, this is out in Mammoth Mountain Ski Resort. He looks happy, dancing. There you go. Good moves. Well, here's the thing. A strong atmospheric river socked Los Angeles County over the weekend. So again, we showed you some of the rain that they had, but this is the snow. Look at all that snow. Could you imagine having that much snow? 18 inches of fresh powder over a 3-day period. So the ski trails out there, Mammoth Lakes, Cali, Mammoth Mountain, the skiers out there obviously are going to be really happy, and obviously clearly that mascot there. Just a reminder, we did have our winter weather outlook. If you haven't had a chance, go to WCA.com, and you can find the episode as that aired here this week if you want to know a little bit more about what we can expect for the upcoming winter. So we are looking forward to that. Will we get snow like Mammoth Mountain there? I don't know. Go back and check out the forecast. Okay. Coming up, it is our second part of the show here. Again, Andrew Guertin over at the U of I, and did some really interesting research. And yet we're linking some things together here. We're going a little deeper on the interaction of kind of the weathering of rocks and the impacts that it can make on our climate and some of the studying and kind of what he has learned. So that's coming up. Stick around. It's Behind the Forecast, and we will be right back.
From WCI 3 Plus, with your host, Kevin Lighty, this is Behind the Forecast.
Welcome into Behind the Forecast. I'm Chief Meteorologist Kevin Lighty. Thanks so much for joining us here again to the second part of the show. We always do an interview segment. We talk to someone that is in the science world, the weather world, and we have got a unique guest here with us here today. We're going to be talking about the carbon cycle, okay? Most of us, hopefully, kind of know a little bit about the carbon cycle, kind of some of the basics there, how the earth kind of breathes. You know, you got photosynthesis and respiration, consumption, decomposition, combustion, ocean exchange. I know it's a lot there, but we're going to get to the bottom of a lot of this. Those are kind of some of the faster moving parts to the cycle there, but there's a much longer carbon cycle that's kind of happening that maybe you didn't learn in school. So today, I am joined by Andrew Guertin. He is a fourth-year PhD candidate in the Department of Earth Science and Environmental Change at the University of Illinois Urbana-Champaign. And there he is right there. You recently authored a study looking into landscape aging, correct? And again, here to tell us a little bit more about some of that research about the Earth's longer exhale. Does that sound about right?
Yeah, I'm excited to be here.
Well, yeah, thanks for joining us here. So again, Andrew, I'm a meteorologist. I talk weather all the time. I talk about rain a lot. And so let's get into kind of, what happens after my forecast. So here I am. I'm talking about it's raining, okay? And these rain are coming down and they're hitting rocks. Talk a little bit about what's happening and what is chemical weathering for those that are maybe new to that kind of term.
Yeah. So chemical weathering is it's the process of our rocks or solid phases interacting with the weather. So exactly what you're saying, like when it rains, that water, it comes down, it interacts with the atmosphere and it becomes a little bit acidic. And when it hits the rocks on the surface, it dissolves a little bit. So that rock is losing a little bit of itself, and then that water is really taking up what came out. And the other half of that process, that's our dissolution, is the precipitation. So that water, as it picks up different elements, so like our sodium, our calcium, our magnesium that we talk about in like our human supplements or like nutrition, those are dissolved in the water and they'll precipitate out and they'll form new minerals, new rocks. And so it's kind of like the Earth's process of like kind of setting things right. So those rocks that are dissolving are stuff that form deep in the earth from our volcanoes, from magma. They come up, they form really deep in the earth where it's really hot, and they come to the surface and they're like, this is weird. Like, what is weather? What is rain? Why is it so cold? I'm not comfortable. And those rocks, those minerals, they interact with the weather and they dissolve and they become something more stable. We call our secondary minerals, or the stuff that forms on the surface. And so this rock is more stable. It's more comfortable at the surface, is kind of like how I like to think about it. It wants to be here.
So I think there may be some people out there that maybe don't realize that over a long period of time, rock becomes soil. right? And that's kind of a basic kind of thing, but that takes a long time to happen. And that's kind of what that process is, right?
Yeah, exactly. So these primary minerals, these rocks that form from volcanic settings, they're not good for us to grow anything on. They're hard. They don't store water very well. They run off. Like that's not much is living there. But then you look at somewhere like Illinois, that you have this rock that's been exposed for millions of years now at the surface, and you get these really nice soils. And those soils are made up of a mix of different minerals, but a lot of these secondary species that are like comfortable at the surface condition, like are clays. So looking at those clay phases that make Illinois soil so good have formed over millions of years from primary minerals that have been dissolved and then reprecipitated.
So that's why this is some of the richest soil in the world, the country.
Yeah, no, Illinois soil is great. It formed it's like rock that was exposed during like the end of the last ice age, formed from glacial tills and like really, really rich clay-rich soils. A lot of these secondary minerals that form and make great for agriculture.
So with the weather happening, more intense rainfall, warmer temperatures, does that kind of speed up that chemical weathering? Or are you seeing more of that? And what kind of impact does that make?
Exactly. So these weathering processes speed up when it gets warmer and when it gets wetter. And so in the short term, like those processes, like they speed up, but it's hard to see. But like over long millions of years, that's really what dictates like the Earth's climate. So as the climate gets warmer, usually like we think is like a response to in geologic time, like the greenhouse effect. It gets warmer, it gets wetter, and then you weather more rock. More rock dissolves, and then you end up pooling CO2 through that process as new rock forms. It removes CO2 from the atmosphere and it gets stored as a new type of rock, a carbonate rock. And it removes CO2 from the atmosphere and it reduces this greenhouse effect, and the climate gets cooler again and it gets a little bit drier. And now this weathering process has slowed down and the climate is kind of restabilized. And so over millions of years, the interaction between the weather and the rocks is really like a balance. It's a little dance of get a little warmer, get a little cooler, and it finds its balance over time.
Kind of those cyclical changes that we get over long periods of time. Like I said, it may be hard for people to understand the time frame because we're talking in such long terms and not what people normally think in a 15, 20 year kind of cycle. These are millions of year processes that are happening.
Yeah, we're looking on periods like when the dinosaurs were here around.
Sure.
Like tens, hundreds of millions of years.
Now, the dinosaur's not really a big fan of rocks because, one, I think it put them to extinction. Am I right?
Yeah. Interesting. Like, there's a lot of theories around like those extinction events and like how that related to climate and the climate effects from those meteorites too.
Sure.
That interaction of the atmosphere and the rocks.
Interesting. So, tell me a little bit more about. So, you're doing a recent paper, okay, and it focuses on this landscape aging. Took place at an evolution observatory in Tucson. Is that right?
Yeah, it's at the Biosphere 2 site in Tucson, Arizona.
Oh, and what is the Biosphere 2 like?
Well, it was originally like an insulated station built in 1990. It was like almost like a pop culture phenomenon of that time, where these scientists people, I don't know if you call them scientists, were like, can we self-sustain in this giant ecosystem? And they called it Biosphere 2. Earth is Biosphere 1. And since then, the facility is bought by Columbia, and then now University of Arizona operates it, and it's turned into a research station where we can observe and monitor like real analogs for the real world in a controlled setting where like you're isolated from all those uncontrollable aspects of the real world. So
they track some of the elements there, germanium, silicon, to see how chemistry changes.
Yeah. So one of the stations at Biosphere 2, what I was working on, is called the Landscape Evolution Observatory. So at that site, we took some really what we call young rock, which we kind of age the rock here as relative to how long it's been exposed to the weather, how long it's been exposed to surface conditions. So this was rock that was taken from deep underground and applied to the hill slopes. We're like, how can we observe how soil forms, these early stages of chemical weathering that develop a new landscape? So similar to like what happened in Illinois millions of years ago, that like slowly developed its really rich soils, we're now getting to observe in real time what the initial stages of that landscape development looks like.
Young landscape versus old landscape, kind of what exactly kind of is, what does that mean to be an old landscape?
Yeah, it's like it's a reflection of how long that current iteration of the landscapes really existed. So you think of like the start, like the birth of a landscape of being like a volcanic eruption where new rock forms, or you have a really massive landslide where all of the surface soil has kind of been brushed away and now you have just rock that's never seen the surface. And so that young rock is something that is really unstable, uncomfortable at atmospheric conditions, and it reacts really quickly because it just doesn't want to be there. And so it's forming these new, more stable phases much quicker. Whereas a landscape like in Illinois that's millions of years old, consider that that's a more mature landscape. It's reached its comfort stage. It's in the old stages of life. It knows what it likes. It's forming, like it's reacting slowly. It's pretty comfortable, and not a lot's going on. Stuff is going on. I'm gonna get in trouble for saying that, but not nearly as much.
Sure.
So these young landscapes react quickly, change really fast, and because of that, there's not that many traditionally on Earth at any given time. Like if you have landscapes that last millions of years and they don't change that quickly, having ones that are only 5, 10, 20 years old is really rare. Like how often do you have a volcanic eruption? Like every few years, not all of them are that big. But where we're interested in it is humans speed up this process really quickly. Like we mine the earth for like crucial elements, and we do that, we expose a lot of rock to the surface. When we've noticed in recent years a lot of glacial retreat that is exposing, similarly to what happened in Illinois. This rock that was covered by glaciers, protected from the atmosphere, is now exposed. Those glaciers are gone. The landscape has changed. And so that's now a young landscape that's rapidly evolving. And we want to understand what's going on. Like what is happening to that landscape? What's it going to look like in 10, 20 years? But also, how is that going to affect us? How is that going to affect the water coming from that landscape? How is that going to affect the vegetation that grows there? How is that, like, how long until that land is fertile? How long until, what is it giving to our waterways? Do we have to clean it out? Is it good for us? Like, can we drink this water that's coming through these young landscapes? Like these, we want to understand them.
When you guys did, some of the studies and whatnot, what were some of the key elements that came out of your study there that you could really take and run with it in terms of what you learned?
Yeah. So the focus of my study was looking at two elements in particular: germanium and silicon. So silicon is like the second most abundant element on Earth crust after oxygen. It's in like all of our rocks. It's everywhere. And germanium is kind of like silicon's little sister. Like it's not, you don't really notice it. It's pretty rare. It's not very seen that often, but it follows silicon. It likes to kind of just, wherever silicon is, it kind of goes with it. And so what we looked at, why we were looking at this ratio in particular, is when certain rocks form, some of them like germanium more than they like silicon. And so they'll take up more of that germanium and leave more of the silicon in solution. And what that does is we can now measure that water and see what's left, how much germanium is left, how much silicon left, and can we now calculate what else formed that we can't see. So it's like from water, you're kind of piecing together what happened, how that water got there. And these two elements kind of bounce back and forth of what's dissolving, what's precipitating, and they make a nice balance that we can learn from.
So this kind of helps us harness the Earth's natural carbon cycle.
Yeah. So the the component of carbon storage, I think, is
Yeah.
really interesting,
Sure.
and something that people are talking about using this young reactive rock because it reacts quickly. That dissolution and formation of carbonate minerals removes carbon from the atmosphere. So people talk about human like CO2 emissions and like how much carbon's in the atmosphere, and it's going back and forth with trees and deforestation, forest fires, and people talk about these issues. But where that carbon really gets removed from our active human system is in the rocks. And by using this young reactive material and applying it to natural landscapes, the idea is speeding up that process that happens on millions and millions of years and having it be relatively significant on human timescales, on the 10-year timescale. And so that's something scientists have been looking into, and something that's really developing. We're trying to understand how realistic that is and what other complexities are we not considering.
So if we are doing, manipulation to geologic carbon cycle, what kind of issues do you run into in doing something like that?
Well, the idea in theory is really good. In practice, there's a lot of unanswered questions. So how much of, where my study was looking at in particular is how much of that silicate rock. So there's the silicate rocks that form basically from silicon, and there's carbonate rocks that form from carbon, and their base is carbon. And that's what you want to form because that's storing carbon from the atmosphere. But when silicate rocks dissolve, they can also form silicate secondary minerals. And that's what you see as the clay minerals that make up Illinois. And so we want to understand how much of those silicates are forming and how much of those carbonates are forming. And so tracking this germanium silicon is one tool for seeing how much of those silicates are forming. And so when you apply these like techniques and you want to study them, you want to understand how much carbon is really being stored. Like, is it worth the money? Is it worth the effort of mining up this fresh rock and applying it to our agriculture fields, which is what people are starting to do and wanting to do, and how much of that carbon that they're saying is getting stored is actually getting stored. And so that's kind of the ongoing research question and debate.
So I guess kind of what's going to be next step for you now that the study is published? Kind of where do you go from here? Like, what's the next steps?
Yeah, I mean, the next steps is one looking at, so we've only seen like 10, 12 years of evolution of this hill slope. One, want to see what it continues to happen there, but two, also taking this information that we've learned and applying that to real world, natural, young, rapidly evolving systems and seeing if we're getting the same results. We're getting the same evolution in these secondary phases over time, and kind of backing that up with more data and real world applications. Because what you do in one really controlled facility is not going to necessarily relate once you add in all of the unexpected effects of, now you have plants, you have animals, you have weather patterns that change, you have storms, you have flooding. All of these things make it more complicated and more real. And so that's kind of where you got to go next.
Interesting. So we've just got a little bit more time here, but as somebody is out there that's watching this, and in kind of maybe some of the simplest terms that you could say to them, why is something like this important to continue to learn about and keep tabs on, so to speak?
Yeah. In simplest, straightforward terms, I'd say, like, when you do something, you want to know what's going to happen. When you mess with the climate, when you mess with the environment, you want to know what's going to happen. Is it good? Is it bad? And right now things are changing so quickly that it's more important than ever to have the tools, have the techniques, the understanding to model what's going to happen in the future, but also observe what's going on now. And so we are really looking to build those techniques, build that toolbox of ways to understand how our environment is changing, how that's going to change, and how we can harness the tools that exist to make the environment more compatible with human life, but also in a very responsible, intelligent, careful way, because you don't want to create more problems.
We've got enough as it is.
Yeah.
Right?
Yeah.
So there we go. Well, listen, I really appreciate you jumping here with us. Fascinating topic there to kind of get into that, deep dive kind of stuff and learn more about it. Sounds like you're doing some fantastic work over there. So we appreciate you coming in and chatting with us.
Yeah. Thank you for having me.
All right, ladies and gentlemen, that is Andrew Guertin. And I tell you, that guy knows his rocks. That guy knows his rocks. All right, guys, I appreciate you guys joining in here with us once again for another edition of Behind the Forecast. Thanks so much for watching right here on the WC3 Plus app. Have a great rest of your day.